So in this video we have got an indefinite integral that I'd like you to calculate, and on the next slide there's a detailed solution and some comments. So look at the integral, have a go at it with pen and paper, and then come back and you can find the detailed solution. Before you start writing it though, I would suggest that you look at this a little bit carefully before you actually start the calculations. That's just a hint. Okay, see you in a short while. Welcome back. Let's look at the solution. So here is our integral. And one of the first things you might recognize is that this is really two integrals. There is a difference of two terms in the numerator. So we could break this up into the integral of 1 over 1 plus t here, minus t over 1 plus t, a separate integral. And this is an easy integral. It's a logarithm. We'll see this sort of thing in a moment. But this is not quite as easy, and we'd have to do a little bit of work. And what this is actually telling us is that really this decomposition, although it looks very natural just to break this up into 1 over 1 plus t minus t over 1 plus t, although it's true, it's not ideal, and we can use algebra to make life easier. Now, algebra very often involves multiplying by 1, in other words, multiplying and dividing by the same thing in a carefully chosen way, or adding 0, by which I mean adding and subtracting the same thing in a carefully chosen way. So let's look at this. Supposing instead of t I had 1 plus t, then 1 plus t over 1 plus t is 1, and that would be very easy to integrate. So if I just look at the integrand now, and I say, well, we've got 1 minus t over 1 plus t, and what I would like to do is I'd like to write it over 1 plus t, but then here, when I had minus t, I want to have minus 1 plus t. So, and there was the 1 initially there, so that's that 1, and then here we've got minus, and now not t but 1 plus t. So this, if I was to expand it, is minus 1 minus t. The minus 1 is new, so what I have to do is I have to cancel it by adding another 1. So everything that I have done here is I have added 0. I have taken minus 1 from the numerator of the integrand, and I've added 1 to the numerator of the integrand. So I have effectively added 0. So this can be rewritten as 2 minus brackets 1 plus t all over 1 plus t. And this level of algebra, going from here to here, you can verify it just by expanding, is very useful, because now if we go back to our integrand, we say that the integral of 1 minus t over 1 plus t integrated with respect to t is equal to the integral of 2 over 1 plus t integrated with respect to t minus the integral of 1 plus t over 1 plus t, and they're going to cancel in a moment. It's just going to be the integral of 1. So we can now perform this integral using inspection. This is going to be the integral of 1. So what we will obtain is, so it's 2, and then it's going to be the logarithm of 1 plus t. So let's just check that this is correct. If we differentiate the logarithm, we're going to get 1 over the argument. There's a 2 out here already. Over the argument is 1 plus t, so we'll get that. And then from the chain rule, we would multiply by the derivative of the argument to the log, and that is going to give us 1. The derivative of 1 plus t is 1. So we would indeed obtain 2 over 1 plus t. This is correct. And then for the second term, we are integrating 1, and that is just minus t. And now on this side, we have calculated both of these indefinite integrals, so we ought to add an integration constant to show that there is an additive ambiguity. So this is our result for the integral, and you can see, I hope, that this is much easier if we use this decomposition compared to this decomposition. And this is really leading into topics like polynomial division, but it's a fairly simple algebraic manipulation, and it makes life easy for us. So if you'd like to have a go at another exercise of this form, what you can do is you can calculate the following integral. So it's 2t minus 5 divided by t plus 1 all squared, integrated with respect to t. And what I'd like you to do is to use the methods above and to show that this integral is equal to 2 times the logarithm of t plus 1 plus 7 divided by t plus 1 plus an integration constant. And the solution is on the next slide, but if you'd like to, have a go at it first. Okay, welcome back. Let's go to the next slide. So here is the integral from the previous slide at the end. And again, our strategy is to rewrite the numerator. And what we're looking to do is to replace t here by t plus 1 so it can cancel one of those powers. So to do that, what I'm doing here, just looking at the integrand, is I'm adding to t plus 1, but of course it's multiplied by 2, so we have 2 times t plus 1, so effectively I've added a 2 to the numerator, so I must subtract it to leave the numerator exactly the same, but written in a slightly different way. So our numerator is 2 times t plus 1 minus 7, and I've now here broken it into 2 pieces, the minus 7 over t plus 1 squared, and the 2t plus 1 over t plus 1 squared, and that means we can cancel one of the factors of t plus 1, and we are left here with 2 over t plus 1 to the power of 1. So we put this in as our integrand. It's exactly the same algebraically, it's just written in a helpful way. And then the 2 here I can pull out front of the integral just to make it look a little less intimidating. And similarly here I pull the minus sign in front and the factor of 7 in front. So now to calculate the integrals, what I do is I say, well, to get 1 over t plus 1 by differentiation, I'd expect to have a logarithm. So I'm going to say that this is going to be the logarithm of t plus 1. And if I differentiate that using the chain rule, I will get 1 over t plus 1 multiplied by the derivative of the argument, but that's just a factor of 1. And that shows us that we do need in front here a factor of 2. And now if we differentiate that, we get 2 divided by t plus 1. Similarly here, when we integrate this, this is to the power of minus 2. So if we integrate it, we'd expect to add 1 to the power, or to put it differently, if I write 1 over t plus 1, which is t plus 1 to the minus 1, and I differentiate it, I would obtain the following. So this is t plus 1 to the minus 1. If I differentiate it, I multiply by the power, so I'd multiply by minus 1, and I want a minus sign, so that tells me that it should be a plus sign here, so that overall I will obtain minus when I differentiate this. And I would then have t plus 1 to the minus 2, because we subtract 1 power, so we go from minus 1 to minus 2, and that's exactly what we want here. This is t plus 1 to the minus 2, but we need that power of 7, so let me just change this 1 here in the numerator into a 7 and add an integration constant. So that is our value for this integral. And with that, I will stop this video.